so P10.1, forces and motion. What we're going to do this time is we're going to link up everything we know about forces with everything we know about motion and show how the two are connected. Okay, so if you look at this diagram here, this diagram shows a simple experiment that we do to show how force and acceleration are linked. And the way that we do that is we provide a constant force here, going downwards, divided by these masses and gravity. We put some masses on top of a trolley, and we measure the acceleration using a light gauge. And we have a little thing on the end of this piece of string here called a pulley. And that pulley, the job of that pulley is just to reduce the friction in the system. Okay, and then when we do that, we'll get a table that looks a little bit like this, where we have the mass in grams, 100, 200, 300, 400, 500, 600, because each time you do it, you add an extra 100 grams on the top. And then a measurement of the acceleration from the light gauge in meters per second per second. Okay, and then we want to plot that as a graph here, okay, where this one is your acceleration and this one is your mass. And as you can see, that as you increase mass, acceleration decreases. And what that means is, well, the gradient is acceleration divided by mass, which means that acceleration is proportional to 1 over the mass. And when you've got this 1 over, and we're talking about the symbol here being proportional, what we say is that it is inversely proportional, because 1 over something is the inverse. So we say acceleration is proportional to 1 over the mass. On this one, we can then turn that, in physics we can always turn that into a times a constant. So if you can say that something is proportional to something, you can say that it is times by a constant. And in our example, the thing that was constant was one of the things that we were controlling. It was how much force we were giving the system. So we said for a given force, then you're going to get a certain amount of acceleration. Okay, for a given mass. And in the example here, you can see that that is roughly 1.4 newtons each time, because if I've got 100 times by 14, I'm going to get 1,400. But I need to convert that into newtons by taking my grams and turning it into kilograms. And do that by dividing by 1,000. And if you look each time, that is roughly 1.4 each and every time. And that starts to lead us towards Newton's second law, which is that acceleration is proportional to 1 over the mass, and the force is equal to mass times by acceleration. And when we come on to momentum, I'll give you a bit more detail about Newton's second law.